Let us study the dynamics of circular motion. Whenever we use the word dynamics in physics, it implies that we would be analyzing the forces involved in any given situation that we are studying. So herein is a situation wherein this particle is undergoing horizontal circular motion. This horizontal circular motion is supported by one single string. This is the string of length L, and this string happens to be massless compared to the mass of the particle. So this is the particle, let us say P. This particle P is undergoing or performing horizontal circular motion as shown. R is the radius of this horizontal circle, and theta is the angle that the string joining the point P to the point, let's say M, makes with the vertical. So by alternate angles, this angle is also going to be theta. So herein we can understand that only the tension force is the force that has a component in the horizontal direction. Other forces acting on the particle are only gravitation. So there is only one single force apart from tension that is acting on the particle. So if we do analyze the particle, then we understand that this is the force of tension T, and let us say this is the gravitational force mg. So T has a rightward component. The rightward component of T is going to be equal to T sine theta, because it is the component that is away from the angle theta, and we know that the component towards the angle theta is going to be cos theta. So the vertical component of tension is actually going to be T cos theta in this particular case, and this component is going to be T sin theta. Now since the particle is moving in a horizontal circle, there is no vertical motion of the particle. So the vertical component of tension is going to be balanced because of mg. So there is no net force in the vertical direction, and the vertical component of tension, namely T cos theta in this particular case, will be balanced by the gravitational force mg. So what I can write over here is T cos theta is equal to mg. Also T sin theta is equal to the force that is acting towards the center. Now whatever force acts towards the center in horizontal circular motion, that force happens to be the centripetal force, the net force acting towards the center, and this particular centripetal force is the one that is responsible for the so-called turning of the particle, the quote-unquote turning of the particle. Without the centripetal force, the particle would move along a tangent and it will not perform circular motion. So this centripetal force is acting towards the center. So T sin theta is thus going to be equal to mv square upon r. V square upon r happens to be the centripetal acceleration. This comes in from the kinematical study of circular motion. So this topic assumes that you already know that the acceleration in the horizontal direction in this case, or in general towards the center, called as the centripetal acceleration, happens to be v square upon r or omega square r at that particular instant. Here the particle is undergoing horizontal circular motion with a constant velocity v. So this acceleration centripetal is going to be constant, which is matched by the constant force T sin theta. Now if we do divide these two equations, we get T sin theta upon T cos theta is equal to mv square upon r mg. So after performing the due cancellations of T and mass m, we are left with sin theta over cos theta. So that is tan theta. Tan theta is going to be equal to v square upon rg. Or in other words, v square is going to be equal to rg tan theta. That is, v is going to be equal to under root of Rg tan theta.